So just some words about Aiko. So we delivered 130 gigawatts of PV cells mainly. Until 2022 we were a pure cell manufacturer. And we have a very, very strong R&D. And this brought us to the case that we were one of the developers and drivers of this ABC technology. At the moment we have roughly 10,000 employees. This is shifting quite fast. I think last year we had 17,000 employees, but we heard about the cost decline of the cells and modules, and this affects very, very much the industry. So we have 20 R&D 20 plus people in the R&D, and we have 3 R&D centers. One of the R&D centers is in Freiburg. I'm happy to serve also as managing director of the sales team in Düsseldorf, so that's why you can find me at the booth and hoping to sell gigawatts of solar modules. By Facebook, okay. So some of the milestones, I don't want to go into detail, but what we are very proud is that we are now leading the Taeyang News module charts since 26 consecutive months. And this is because we, let's say, introduced the spec contact as the first ones, except Maxion for sure and SunPower, or now TCL, as we discussed before. But I think what we really made in China is that we have the art of production. And to bring this to mass production was really a big step forward. So history of PV cells, everyone knows, so I like this. So I started with PV industries in the early 1990s. At that time, dye-sensitized solar cells. I don't know if anyone remembers. Okay, Rado, thanks a lot. And so later on, we can also think about if there will be something beyond back contact. My personal feeling is that back contact now is the end of the line for single junction cells. And here are some of the reasons why this is the case. So we are achieving in the meantime cell efficiencies in the laboratory at least of more than 27.2%, and with the highest efficiency modules more than 25%. So no front metallization, fully passivated front surfaces. So we have this partial shading and passivated rear contacts, bringing together the summary that there will be, in my opinion, nothing beyond single junction silicon than back contact. So in the beginning, no one thought that back contact can also be bifacial because both contacts are on the back side. We heard in some talks before, and there is a lot of work being done because if you want to go to utility scale especially, bifaciality is mandatory, and there was this nice conference last year in Zhuhai, and we are glad that by improving the electrode and having the finger widths reduced, having the end poly reduced, optimizing the morphology, and the PN run junction having achieved 75% bifaciality rates. So bifaciality is not everything, because let's say if I would have a 100% cell on the front side, I can live with 0% back side efficiency, but let's say as we never can achieve this, 75% is something which is quite important for utility installations. So if you are in our booth, we have the modules for all the scenarios, residential, C&I, and utility, but the technology is always the same. The module size for sure is a little bit different, and the connection is a little bit different, but it's all back contact. As we introduced this back contact now in 2023, so we thought about what else can we do if we think that back contact is the end of the single junction. Then what one can do is really to optimize the module, especially the active area. So you can do very clever packing. You can bring the string connectors to the back side, so you have much more active area, and this is again something which is, I would call, the art of production. you have to be able to produce this in mass production, and that's the next step to achieve these very high efficiencies on a module level. What we are now doing is we're introducing at the Intersolar, this is what we call Navigator module. So this was also, let's say, by some American companies in the past known, that you can monitor every single module with an intelligent junction box, and which carries about the power line. So this means you don't need an additional connector, and therefore it's what we heard about from TÜV or from Alessandro before, reliability can be monitored quite well. So this is something I talked before a little bit. This is the infinite module. It's a third generation of our back contact module. And within this infinity module, we use the same cell technology, but improve the module technology a lot. If you see it in our booth, it's completely black, because let's say we increase the active area very much. So what I like very much, and here I also invite you to our booth, is this micro crack resistance. So if you compare, let's say, a single PERC cell or a TOPCon cell or anything else which is contact on both sides, you always have to connect front to back side. And this really gives this gives stress to the cells. And with back contact, you have both polarities on the back side, which makes a much easier cell connection. And this brings really, really nice effects in respect to micro crack resistance. You know, you have micro cracks, especially at installations. Yeah, in installation, it's a little bit harsh. People are walking on the modules, and you have, let's say, in strong wind areas, you have a lot of tension. So this gives a lot of more stability in this micro crack, and we have this little experiment there placed on our booth, which I like a lot. So two cells are placed in a machine, and we are cracking those cells. So you see the TOPCon cell is totally destroyed. Also our cell is very much destroyed, but if you connect it, then you can see that ours still is generating electricity, while the TOPCon is producing nothing. And this is just a good example that this micro crack resistance is something also what you can see for reliability, Alessandro. Yeah, so we guarantee, and we do it with Munich Re, that our modules are stable for 30 years. For a company, this is quite mandatory to guarantee this with some reassurance companies. So this is a big topic for us. And especially with this one, we are sure that we can bring profit to the market. So if you want to maximize the energy yield, that is what we are trying to do. So we have this very good temperature coefficient, mainly driven by the voltage. So we have 0.26 compared to a TOPCon, maybe 0.29, maybe some have 0.28. And we have a very good degradation rate. So this gives us, over the years, a much higher energy yield. And we have some independent research from CIE Ines, where we got a module grade of 107. So if someone wonders that there are more than 100% possible, this is compared to the nameplate. So this means the energy harvest compared to the nameplate can be higher than 100%. Maximizing the energy yield, I told before that we have other things. We have this shading tolerance. I don't know in which talk it was before, I think Radus maybe, that with both contacts on the back side you can decrease the throughput voltage, and we can have, let's say, 4.5 volts at the moment, which means we can integrate more or less a bypass diode in every cell. And there are also some very nice effects which we can show you in our booth, where we can play around with shading, and there you see the voltage drop of let's say, standard modules compared with the ABC modules. And this means if you do it cleverly, then with some shadings we can generate 30% more energy. Because in a standard butterfly connection, a module, if you shade one complete cell, then let's say 1/3 of the module is shut down by the diode. And in our situation only one cell is bypassed. Okay, all this leads to this 30-year life cycle improvement of the energy harvest. And yes, Alessandro, that's why I like your talk. It's extremely important. And with all the customers, they are dealing with their business models and they calculate for 30 years. So someone has to guarantee, and I hope that Munich Re will stay stable, even if we sell some gigawatts more. So otherwise, they have to pay for the energy. But let's say we can't do much more than accelerated testing. Our modules were introduced to the market in 2023, but that's why it's so important to have TÜV and other organizations to do this accelerated testings. We have a TÜV site even in our production site in EU, where we do a lot of tests, because if you want to implement a new technology in the market, it's extremely important that the customers can rely on it. And for sure, no one can guarantee for 100% that everything will work as we believe, but you can test as much as you can, and that's the only thing you can do. So there are some examples with this increased efficiency harvesting, which you can get at the moment. There's an interesting project in Bosnia and Herzegovina where a 64 megawatt peak project was planned. And they have chosen different cell types or module types, and obviously they did some miscalculations with the available land. And the nice thing was that only with the ABC modules they were able to fulfill the requirements from this IPP company. And another nice example is one installation we had here in Germany, where the original design was for 120 megawatt peak area, so to have TOPCon modules. Then we were able to convince the investor to use our modules. So he had to invest a little bit more, but the installation capacity increased by 6%, and the 30-year total return increased also by 6%. And this is the business model we are running. So our modules are a little bit more expensive, but with the higher energy yield and the lower LCOE, we believe that it's the best technology even in utility projects. So this is the end of my presentation. I invite you very much to visit us in our booth, and looking forward to a successful Intersolar. Thanks a lot.
Thanks.
And that's my